Bathtubs equipped with an air bubbling system, but lacking water circulation, do not mandate bonding of the hot and cold water pipes to the circuit grounding wire. The reasoning stems from their classification. These bathtubs are not categorized as hydromassage bathtubs. The defining characteristic differentiating a hydromassage bathtub is the presence of a pump dedicated to water circulation. Without this pump, the electrical safety considerations differ. Furthermore, the positioning of the air circulation motor plays a crucial role. In this particular scenario, the motor is situated below the tub. This location mitigates the potential risk of electrical shock, even in the absence of bonding between the hot or cold water pipes and the circuit grounding wire. To elaborate on the concept of bonding, it's essential to understand its primary purpose. Bonding, in the context of electrical safety, establishes an electrically conductive path between various metallic components within a structure or system. This path ensures that all bonded components maintain the same electrical potential. In other words, there is minimal voltage difference between them. The importance of this lies in preventing dangerous electrical shocks. If a fault occurs, such as a live wire coming into contact with a metallic pipe, the bonding system provides a low impedance path for fault current to flow back to the source. This high current flow triggers the overcurrent protective device, like a circuit breaker or fuse, to trip and disconnect the circuit. Without proper bonding, a fault could energize metallic components, creating a shock hazard for anyone who comes into contact with them. In the case of hydromassage bathtubs, the presence of a circulating water pump introduces a different set of electrical safety concerns. The pump, being an electrical appliance in close proximity to water, increases the risk of electrical shock. To mitigate this risk, electrical codes typically require bonding of the water piping system and other metallic components within the vicinity of the hydromassage bathtub. This bonding ensures that any fault current will quickly trip the circuit breaker, minimizing the duration and severity of a potential shock. The National Electrical Code, or NEC, provides specific guidelines for electrical installations, including requirements for bonding and grounding. Section 680.74 addresses spas and hot tubs, which often share similar electrical safety considerations with hydromassage bathtubs. This section outlines the bonding requirements for metallic components within the vicinity of these installations. It's important to consult the latest edition of the NEC and local electrical codes to ensure compliance with all applicable regulations. While air bathtubs without water circulation may not require bonding of the water pipes, it's still crucial to ensure that all electrical components associated with the bathtub are properly grounded. Grounding provides a path for fault current to flow back to the source, helping to protect against electrical shock. Typically, the motor that circulates the air will have a grounding conductor that must be connected to the electrical system's grounding electrode system. This grounding electrode system typically consists of a grounding rod, metal water pipe, or other approved grounding electrode that is connected to the electrical panel's grounding busbar. The grounding busbar is, in turn, connected to the neutral conductor, creating a low impedance path for fault current to flow back to the source. It is also important to note that electrical codes may vary depending on the jurisdiction. Local electrical inspectors have the final say in interpreting and enforcing the code. Therefore, it's always recommended to consult with a qualified electrician or electrical inspector to ensure that all electrical work is performed in accordance with the applicable codes and regulations. Proper electrical safety practices are essential to protect against electrical shock and fire hazards. When working with electricity, it's always best to err on the side of caution and take all necessary precautions. This includes turning off the power at the circuit breaker before working on any electrical components, using insulated tools, and wearing appropriate personal protective equipment. Never work on electrical equipment when you are wet or standing in water. Water is an excellent conductor of electricity, and the risk of electrical shock is significantly increased in wet conditions. If you are unsure about any aspect of electrical work, it's always best to consult with a qualified electrician. Attempting to perform electrical work without the necessary knowledge and experience can be dangerous and potentially life-threatening. In summary, while air bathtubs without water circulation do not typically require bonding of the water pipes, it's essential to ensure that all electrical components are properly grounded and that all electrical work is performed in accordance with applicable codes and regulations. Consulting with a qualified electrician is always recommended to ensure electrical safety. Furthermore, understanding the distinction between an air bathtub and a hydromassage bathtub is crucial for determining the appropriate electrical safety measures. The presence of a water circulating pump in a hydromassage bathtub introduces additional electrical safety concerns that necessitate bonding of the water piping system and other metallic components. By adhering to these guidelines and consulting with qualified professionals, you can ensure the safety of your electrical system and protect against electrical hazards. The NEC is updated regularly, typically every 3 years, to reflect advancements in technology and address emerging safety concerns. Staying up to date with the latest edition of the NEC is crucial for ensuring compliance with current electrical safety standards. Changes to the NEC can impact bonding and grounding requirements, as well as other aspects of electrical installations. Therefore, it's important to consult with a qualified electrician or electrical inspector to understand the implications of any changes to the code. In addition to the NEC, other standards and guidelines may also be relevant to electrical safety. For example, underwriters' laboratories or all develop safety standards for electrical products. Products that are UL listed have been tested and certified to meet these standards. Using UL listed products can help to ensure the safety and reliability of your electrical system. The air circulation motor itself requires proper grounding according to manufacturer's instructions and prevailing electrical codes. The grounding conductor, typically a green or bare copper wire, provides a low impedance path for fault current back to the source, tripping the circuit breaker in the event of a fault. This grounding protects against electrical shock hazards. The location of the motor beneath the tub, while reducing immediate shock risk from water pipe contact, doesn't eliminate the need for proper grounding of the motor itself. This grounding is essential for overall safety and code compliance. Remember, electrical codes that are in place to protect people and property from electrical hazards. Adhering to these codes is not only a legal requirement but also a moral one. Shortcuts or compromises in electrical work can have serious consequences, including electrical shock, fire, and even death. Investing in quality electrical work performed by qualified professionals is a worthwhile investment in your safety and the safety of others. When in doubt, always consult with a qualified electrician or electrical inspector. They have the knowledge and experience to ensure that your electrical system is safe and compliant with all applicable codes and regulations. The integrity of the grounding system is paramount. Regularly inspect the grounding connections to ensure they are tight and free from corrosion. Corrosion can increase the resistance of the grounding path, reducing its effectiveness and carrying fault current. If you notice any signs of corrosion, clean the connections and retighten them. If the corrosion is severe, replace the grounding conductors and connectors. It's also important to ensure that the grounding electrode system is properly installed and maintained. The grounding electrode system provides a connection to the earth which helps to stabilize the electrical potential of the system and provide a path for fault current to dissipate. Regularly inspect the grounding electrode system to ensure that it is in good condition and that the connections are tight and free from corrosion. If you are unsure about how to inspect or maintain your grounding electrode system, consult with a qualified electrician. The size of the grounding conductor is also critical. The grounding conductor must be sized appropriately to carry the maximum fault current that the circuit is likely to experience. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the circuit conductors. Using an undersized grounding conductor can result in a higher impedance path for fault current, which can delay the tripping of the circuit breaker and increase the risk of electrical shock. When replacing or upgrading electrical equipment, always ensure that the grounding conductors are properly sized and connected. The goal is to minimize risk. While the risk might be minimal, ensuring the electrical system follows code and is properly inspected will reduce that risk. The lack of water circulation is an important factor in the assessment. Since there is no water being circulated, the electrical connections within the air bath system are less likely to come into contact with water. This is a significant difference compared to hydromassage bathtubs, where water is constantly circulating near electrical components. The design of the bathtub and its components plays a vital role in safety. Manufacturers of air bathtubs typically design their products to minimize the risk of electrical shock. This includes using insulated wiring, properly grounding all electrical components, and providing clear instructions for installation and use. Always follow the manufacturer's instructions when installing and using an air bathtub. The instructions will provide important information about electrical safety and proper operation. Ignoring the manufacturer's instructions can increase the risk of electrical shock, fire, or other hazard.